This is a presentation on a new consolidating CoinJoin idea that I've been working on for the last few months. My name is Chris Troutner. I am a JavaScript developer, and this is a JavaScript program that I am going to talk about today. This presentation is going to have three parts. I'm going to talk about the problem of maintaining privacy in Bitcoin. I'm going to talk about the solution, and I'm going to give a demo of the consolidating CoinJoin service that I am developing and releasing open source under the MIT license, so everyone is welcome to fork this code and use it. I am not developing it for profit. I'm developing it to improve fungibility and privacy in Bitcoin. I think it's a very important problem that needs to be solved. So, real quick, the problem of privacy in Bitcoin. A lot of people think that Bitcoin is private, and that's actually not true. It's pseudo-private. Because instead of having a name, you have a serial number. And the problem with all these serial numbers, or a hash, a Bitcoin address, those are all the same thing. The problem with it is that while that's nice and you start out anonymous, over time and through the use as the money flows around, it can become de-anonymized. And I'll go over a few ways that de-anonymization happens. But why is this important? So the Bitcoin Cash is trying to be cash. And so if you have experience using like a US dollar, which most people do, like let's say I give you $1 and you go to buy a candy bar with it, no, the person taking that dollar and giving and selling you the candy bar, they don't care about where that dollar's been. And that's called fungibility, the ability of any dollar, if it's dirty and scratched and written on, it's still a dollar and it's still equivalent to a brand new crisp dollar. And that's the fungibility of dollars. And so that's the ideal that Bitcoin Cash is trying to achieve. And so we all know that Bitcoin is used in shady stuff, drug deals, not that I have a problem with that, but also Bitcoin gets stolen and there's these ransoms that get paid for viruses and all sorts of things. So there's always an attempt, or there's always going to be an attempt by organizations to de-anonymize and sort of follow the trail of money because they can, because the ledger is available. So for instance, let's say you get paid, someone pays you with some Bitcoin Cash, and you go to an exchange like Coinbase, and you go to cash out that Bitcoin Cash into your local fiat. Well, whether they do it now or not doesn't matter, but what I anticipate will become general practice is that prior to accepting the trade and giving you the fiat for the Bitcoin, they're going to run an audit on the ledger on your addresses. So because they have your information, your KYC information, and now they have the Bitcoin address that you're trading from, they can look backwards and walk backwards through the blockchain and the transaction ledger and try and find out, and this is all automated, this is all going to happen in software, it's not a person doing this, trying to find the source of the information. So imagine someone pays you and you go to cash out and this audit happens. It turns out that that money originated from a robbery or a drug deal on Silk Road, and now they're not going to honor it, and they probably will have confiscated it. They'll probably take it and then just not give you the fiat. Or let's say some government wants to crack down, and the IRS wants to audit your history, and it's just the point of cash is it's your money. It's not the government's. The government shouldn't have the ability to look at it and audit it, and neither should exchanges. This is sort of the philosophical idea of why privacy is valuable and why people want to achieve it and why it's difficult in Bitcoin. But the biggest threat on an individual level is not the transactions you're doing today. It's the transactions that you're doing today that get looked at in the future. So software will improve. This will become standard. And if we don't maintain privacy, best practices, something you do today will come back and haunt you in the future. And that's why every person should care about privacy. So that's kind of the problem. Let's talk about how privacy is actually lost in a Bitcoin transaction. So here is just a simple diagram of a series of transactions: transaction 1, transaction 2, transaction 3. Now, the most obvious way to lose anonymity in Bitcoin is reusing addresses. So imagine this is address A, and you get paid in address A, and then you go to buy that candy bar. So that's this arrow here. Now imagine if this arrow, instead of going down to the next transaction or address, actually wrapped back around to the original address. So that's essentially you're spending the money, and then you're spending what you're spending, and then what you're not spending gets put back in the address. And that's sort of the most simplest way to implement a wallet, and that's how it used to be done. But then you get this like really rich history on the address that every time you use it, like you're taking a risk of de-anonymizing yourself depending on the transaction. It becomes really obvious who owns that address and what transactions belong to it as opposed to other addresses that maybe belong to other people. So that's one way. So it's pretty common practice these days. All the major wallets, they use HD wallets that let them generate an infinite number of addresses. And so typically the flow looks like what you see here. It's like this dollar would come out. Let's say you're going to buy a candy bar, so that goes out this way. And then instead of putting the payment back into the original address, the wallet will generate a brand new address and send the change to that address. So every time you make a transaction, you get another address, and that's a big improvement. That helps a lot. And like I said, most wallets follow this pattern these days, and that's good. The problem is what happens when you basically are left with pocket change. A little bit of money is left in your wallet, and it's not big enough to really spend on anything, but it might be worth more in the future. So you don't want to just throw it away. What do you do with that? And that's called the dust problem. That's called typically what wallets do is they will consolidate all your dust into a new address, and what that does on the blockchain is it ties a bunch of addresses that were anonymous together. And so a program that's auditing the blockchain can walk backwards and look for those consolidating transactions, and then use that to infer ownership of other addresses and walk back. And so I don't want to go into much deeper detail than this. Suffice to say, if you want to research this topic more, the best place to do it is at developer.bitcoin.com. And if you go to Learn Mastering Bitcoin Cash, this was originally written by Andreas Antonopoulos. And if you go, so I went to this transactions chapter, and you search for UTXO, transaction outputs and inputs. This is the section that explains UTXOs and how UTXOs work in Bitcoin. And there's also another great article on bitcoinism.blogspot.com, and this talks a lot about privacy and best practices and how privacy is lost. And so if you want to dig deeper into this, that's what you want to do. So, but I'm going to leave it here. Just suffice to say, all you need to understand for this demo is that privacy is a problem that is unsolved in Bitcoin today. And so with that, let's move on to the solution. How do you fix privacy in Bitcoin? And one solution that was proposed about 5 years ago, let me pull up Consolidating CoinJoin. So the software I'm going to show in this video is based on this gist, this Consolidating CoinJoin gist right here. So if you go to GitHub and you go to gist.github.com, you can search for Consolidating CoinJoin or my name, Chris Troutner, and that'll pull up. This is the original image for CoinJoin, and this idea, I believe, was originally created by Greg Maxwell, and there's a link here to the original Reddit post. And then here's another example further down talking about CoinJoin. But the idea is that a bunch of people put in a standard amount of money, and then into a multi-signature transaction, and then standard amounts of money come back out. And because there's multiple people participating in it, there's no way to know for sure who, and because the amounts are standardized, there's no way to know who owns what inputs own the outputs. And so this is the idea behind CoinJoin, and it's sort of like this people-powered solution to the privacy problem. And but it's really hard because you've got to get a bunch of people who are technically savvy, or at least have wallets that are technically savvy enough to get together at the same time and coordinate and do this kind of sophisticated thing. And I think that's why 5 years on we still don't really have a solid implementation of this CoinJoin idea. So in thinking about it, I came up with this what I call consolidated CoinJoin, and what it's doing is it's achieving the same thing, and it's also giving a few advantages over the original CoinJoin at the cost of one single disadvantage, which is using a trusted wallet. And a lot of people are disappointed in that, but or like disappointed by that trade-off. But I'm hoping that what this software will show is that it's not a big ask. It's not a big trade-off. But in its essence, how the consolidated CoinJoin works is a whole bunch of people. Each one of these transactions represents a person participating in the CoinJoin. They send them all to an application, an app, that takes all these transactions and consolidates them into one single UTXO, and then the app redistributes the money after the consolidated UTXO happens, redistributes the money, and the only people who know the output addresses are the users using the system and the app itself. And each user has no idea who the other users are. They don't communicate. They don't know. All any one individual user knows is the input addresses and the output addresses that belong to them, that they're using. They don't know anything about the other participants. Only the app has that sort of global information. And the argument I make is that this app can be programmed to delete that information when it's done. And so you can read in here, but for more details. But what I want you to focus on is these two transactions, TX N+1 and TX N+2. I'll refer to these. So TX N+1 is where all the input addresses get merged into a single UTXO, and then TN N+2 is where the UTXO expands and the money gets redistributed back to the users. and this is what anonymizes it, because once they get consolidated, there's no way to know what inputs belong to what outputs, and like mathematically, it's mathematically provable that you really can't infer that information. And so not only can it help preserve privacy, it can actually restore privacy. This is one of the only things I'm aware of that you can do with Bitcoin that will actually improve anonymity that has been lost through like poor transactions, or poor wallet hygiene is kind of the term that's used. So that's the idea. And I'm not going to go any more deeper into the weeds. You can come here and check this out and read this if you want more information. What I'm going to do now is show the software that I've developed. And there are two pieces of software. The first is this bch-cli wallet. So BCH obviously stands for Bitcoin Cash. CLI stands for Command Line Interface. And then it's a wallet. And this is intended to be a hacker-friendly, something that's really easy to hack on. There's not a very sophisticated user interface because you're on the command line. But let me show you how to install this. So this is a virtual machine I set up running Ubuntu, but this would also work on Windows and Mac. The only prerequisite is that you have Node and NPM installed. So I'm not going to cover how to install those, but as long as you have Node and NPM installed, it's going to look something like this. And this works on Windows as well. So let's see. I'm going to connect to my virtual machine. So this is a brand new machine. it's been set up. I have Node 8 and npm 6 installed. And so here's how you install the wallet. You just go npm install, G is for global, and if you're on Linux you might have to do sudo, but if you're on Mac you don't have to, and I don't think you have to do that on Windows. bch-cli-wallet. So that's going to go out to npm, grab the package and install it. And there's going to be times during this presentation where I'm waiting for a block to confirm, so I'm just going to pause the recording and then fast forward. But this shouldn't take very long. Okay, so installed that. That's installed. And so if you go bch-cli-wallet help, that'll bring up a list of commands. And this will grow with time. It'll get more functional. But I'll just show you kind of some basic commands to get started. So listed a wallet. I think this test wallet comes in there, and you can see that it's on the network. So the way you can create a wallet is create wallet, and I'm going to give it a name, demo 01. And if I do list wallets, you can see, and it's a mainnet wallet. And for this demo, I'm actually going to do testnet wallet, so that's with the -t. And the way I know that, or the way you can discover that if you don't know that, is you can go wallet help create wallet. And so it tells you here, if you do a -t, it'll create a testnet wallet, -n, you give it the name. So that's the basic way to work with it. If you do just help, it'll list all the commands, and then you can do help, list wallets, or whatever subcommand, and it'll give you the information. So I've got my demo 2 testnet wallet. I'm going to generate an address. So now that I have an address, I need some Bitcoin Cash. So I'm going to copy this address, and then I'm going to go to, close some of these. I'm going to go to developer.bitcoin.com/faucets. And this is a Bitcoin Cash faucet and a wormhole coin faucet. I actually developed these. So this is how you can get some testnet Bitcoin Cash, and you can see that the address is prefixed with BCH test. That's how you know it's a testnet address. So click this, and while I'm at it, I'm actually going to get another address. Let's see. Oh, because I've already used. Okay, I've already used this, but that's okay because I have another wallet that I can use. So what I'm going to do, for the sake of purposes, this would work for anybody doing the demo. You could just put it in there, but I already used it today, and there's a 24-hour waiting period. So I'm going to pause the recording, and I'm going to send some Bitcoin Cash that I already have in this other wallet to this demo wallet, and then we'll continue from there. Okay, so I sent some money from the other wallet I had to this address. So if I do bch-cli-wallet list wallets, I can see it's there, and right now it doesn't have auto update. Everything's pretty manual. So demo 2, I'm going to update it, and so now you can see that it has the balance. And so if I list the wallets again, now the balance is showing. And so this 0.1 is important because that's what I have the CoinJoin server set to. But that number can be changed. This is just for demo purposes. That's why the amounts. So the idea behind the CoinJoin server is that is that it gets triggered at a certain amount, like 1 BCH or 10 BCH. Right now I have the server set for 0.1, so that way for this demo. But what I'm probably going to do is I'm going to create a public testnet server for people to use after this video, and I'll probably set it at 1 BCH, so you can send any amount to it, but at 1 BCH it'll trigger the CoinJoin. And so the amount of time you have to wait until your money is sort of anonymized is going to change. So now that I have this wallet and I've shown how to install the command line wallet and generate an address and send testnet BCH to it, now I'm going to show you, well actually I already have a server set up at CoinJoin.christroutner.com, and right now I just have this placeholder because there is no web user interface. Eventually there will be. You would scan this, you scan a QR code here with your wallet app on your phone and send the money that way, and then it would send the anonymized money back to you. But in the meantime, I'm going to go bch-cli-wallet, CoinJoin. The name of the wallet is Demo02, and the server is going to be, first of all, let me just show you the help for that. So that's how I know what commands to do. So I'm going to go CoinJoin. The name of the wallet I'm going to use is Demo02, and the server I'm going to use is https coinjoin.christroutner.com. So that just sent all the money in the wallet to that address, or to the CoinJoin server. And I'll get this transaction, and I can monitor the transaction in a block explorer. So you can see it's unconfirmed. And because I sent 0.1, or a little bit more than 0.1, I know that that's going to trigger the CoinJoin because that's what I have the server set to. So when this confirms, the CoinJoin will trigger, and it will send the money back to the address. And because the CoinJoin server is configured to use 0.01 BCH, like in this diagram, oh, this is 0.1. But right now I have it set for 0.01, so when it comes back, so right now if I CLI wallet, list wallets. If I list the wallets, okay, it still looks like it has balances, so I need to update it. So what it's doing right now is it's talking to a full node, and it's downloading, it's getting updates for the addresses stored in the wallet. So there is no full node running locally. Everything here is networked using Bitbox, which is a sort of an API-based wallet. So the balance updated, and you can see it went to 0, and now it's listed as 0 when I list wallets. When this comes back, the same amount, less a couple tiny transaction fees, is going to come back, but it's going to be separated in 0.01 increments, so it'll end up going to 10 addresses, and I'll show you that when it comes back here in a minute. Okay, so it's been a few blocks in the blockchain have been created. And the server accepted the input and it returned it. So if I go back to the wallet, okay, so yeah, so 0. So I'm going to update balances on the demo wallet. Update balances. There we go. So there's the money back, a little bit less than what I sent because of transaction fees, but if I go into where the actual wallet, npm global, where the actual wallet is stored, you can see here that now the wallet is composed of several addresses that each contain 0.01 Bitcoin. So the important thing here is not to get hung up on the fee. People at this point might be saying, well, 0.01 Bitcoin, that's not enough to spend. That's like, I think maybe $5 in today's, but the decimal point can change, you know. So in this example, the threshold for the server was set at 0.1, and it distributed them at 0.01. But those decimal points can move. I could just set the server at 10, and I could have it distributed at 0.1. That would be a little more practical in today's valuations. So that the decimal points can change, and that's an important thing to realize here. So yeah, so this wallet now has the same amount of money, but it has been anonymized. And if there were more participants, or if I submitted the wallet multiple times, every time those would both improve anonymity. And so if you are just a normal user, and I'm just going to list the wallets here. If you're just a normal user and all you're interested in this technology is using this command line wallet for anonymizing your Bitcoin, you can stop watching right now. From here, I'm going to dive in a little deeper on the server software for those people who are interested in the server. And I want to start by saying that even though this is an app that it would be under a centralized control, it's like a centrally trusted wallet, and that's a bad thing. The important thing is that because this is just a node application, it can be run in the cloud. It can run as a .onion service to make the server itself anonymous. And when users use the server, the only thing that they're risking is the money at the time that they submit. You know, they're essentially trusting that the server is going to return the money back to them. And if they get their money back, that's really the only danger to the end user. So I anticipate that people will fork this code, customize it, use it, put up servers anonymously, run them as .onion services over Tor, and that way the server operators can protect themselves from government entities, and they'll also be able to set a fee, and so they'll be able to compete on fees. So let me show you, walk a little bit deeper into the server for those who are interested in the server software and maybe starting up their own server and potentially helping with the development. So this is the Consolidating CoinJoin Server repository, and there's a couple different ways of operating. So I have the requirements listed here, and there's a development installation instructions, and then there's production installation instructions. So let me... Okay, so for production, if you want to play with it, these are the instructions you want to follow. You want to clone this repository, just like you would for any other GitHub repository, and then run npm install to install the dependencies. There's this script called install Mongo. So the server requires a Mongo database. So if you run that script and you don't already have Mongo installed, it'll install it for you. And then the really important thing is to run tests and just make sure everything is running. If the tests aren't running, then you're not going to have much luck. But the tests are very fast. It has 88% test coverage right now, so that's pretty good. And let me just check and see. Yeah, I think I showed all that. And then you can start it with npm start. And now the server's running, and you can talk to your own server using that same command. Let's see. This is the actual wallet I was just using. So where was that CoinJoin command that I issued? There we go. So this CoinJoin command, you can use this server that I set up that I'm going to be doing testing, and I recommend that people join in and help. But you can also now call your local server with localhost, and it defaults to port 5000. So that's how you would do the same CoinJoin running your local development server. And in fact, let me just show you what this looks like. So this is started. But before I do that, I want to talk about production. So production's a slightly different setup. It uses Docker, or more specifically Docker Compose. So I have these tutorials in here on how to set up Docker Compose and how to set up Docker. And what that looks like is you go Docker Compose up, and that starts the server again on port 5000. And so now I'm using a different it's the same thing. It's still the Bitcoin command line wallet. I'm just running it locally, and just want to show what it looks like when I do locally. Make sure this one has a balance. Okay, that's the one I sent. I think this one still has a balance. Okay, so that one still has a balance. So I'm going to do CoinJoin. I'm going to use wallet 4, and I'm going to send it to the local service, local server, localhost port 5000. So there it's submitting all the money in the wallet. And here's the server side. This is what it looks like. Here you can actually see the HTTP endpoints getting called. And let me just walk you through where the code is. The structure gives an idea of the overall layout here, but the important files that I'll touch on is here's the Docker file, and that's what creates the Docker container for production. Here, let's see. Here's the Docker Compose file. It's a YAML file, and that's what starts up the Docker container and the Mongo container. There's a series of bash shell scripts like run image and build image. Those are kind of handy and worth looking at. The actual server is in the bin folder, and server.js. This is what starts when you run npm start or start the Docker container. That's what kicks off the whole thing. There's this front end right here. This is just a dummy placeholder right now. That's in the front end folder. The tests are in the test folder, and the source directory contains most of the code. So in the models, are the MongoDB model files, and then in modules, these are the API endpoints. So the important one is address. This is where the wallet talks to this endpoint, and what it's doing is it's giving. I talk about that a little bit here in the bottom of the paper. But what the wallet app is doing is it's requesting. It's saying, hey, I have these many addresses with this much BCH. Give me an input address for each UTXO so that I don't have to mix my UTXOs, and that's in line with privacy best practices. And then the server gives it a list of output addresses, or actually it generates a list of output addresses that the wallet does locally, and those output addresses are where the server deposits the money after the CoinJoin. And if I back up a little bit, that's the important stuff, and so that's where I'll leave it. I can usually be found on Discord, on the in the Bitbox SDK channel here, and this is the link right here. If you want to put that in your browser, that'll take you to or actually let's just do this one here. If you put this link in your browser, this will take you to the Discord channel and walk you through downloading Discord if you don't use it. And that's where you can find me and ask questions. Also, if you find problems, feel free to create issues, GitHub issues. And I hope that this is stimulating some ideas and getting some developers excited. I'd like to see this thing developed, and I'd like to actually see privacy and fungibility in Bitcoin Cash.